Hey guys, welcome to the start of another project, or should I say projects. These may look familiar to some of you because I actually worked on one of these before. What these are chassis from a Dumont RA-113. I did a full restoration video series on one of these 2.5 years ago. Well, the same owner of that set liked my work and really likes this model and came across two more. And this time around, I'm a little bit smarter about it. When I did the other RA-113, they brought over the entire set, and we lugged it up the stairs, and I worked on it. Well, it's a rather large, heavy cabinet, but what we learned while working on that was that the chassis actually slides out. They're mounted on boards, and if you disconnect the picture tube and the speaker, you can slide the whole thing out. So he just dropped off the chassis and one of the speakers, and he had picked up some replacement tubes on his own. But what I don't have, because it stays mounted in the cabinet, is the picture tube and the yoke. So that will be one challenge to work on this. So I've got a speaker, but I don't have the yoke or picture tube. Now for the picture tube, that's no problem because I can use this, a little Tust CRT made specifically in the 50s because more and more sets were made where the picture tube was mounted to the cabinet, and you really don't want to have to take it out if you don't have to. So these little guys, they have the same deflection angle and same voltage characteristics as the full size. And I do have a lot of spare yokes, so I just need to dig one up that's compatible, and I believe it plugs into this. So I'll need to rig up an octal plug with the right hookup for it. And then here's the bit that plugs into the base of the CRT. I don't know why they did these half sockets. I think it was just to save money instead of doing the full octal socket. Because all of these, they only use 5 pins. So you look on the bottom of them quite often, there are no pins up on the other side because they just aren't used. You got 2 for filament, 1 for cathode, and 1 for the cutoff grid, and 1 for an accelerator grid. And then this is the high voltage lead. So now that I've seen several of these chassis, it's interesting. So you get experience working the same chassis again and again. You notice differences or common features between them. Well, one common feature is that every one I've worked on has had the high voltage lead cut off and the new one spliced in. I believe that's because the original Dumont CRTs had a different type of high voltage connector, whereas all the other standard ones use this type. This is kind of ugly, so I intend to replace them on both of these. This is an old type of insulating material. I've seen this on a few flybacks. And there is flyback down in there, and these use voltage doublers. There are 2 high voltage rectifiers in there, and 3 of these high voltage caps, which I will be replacing. These are slightly different. They're both RA-113s, but one is a B3 revision, and one is not. So they're like 99% the same, but there are some subtle differences I'll show you underneath the chassis. Otherwise, they look pretty clean. Well, not a whole lot of work's been done to them. I'm not sure what this is all about. I don't know if it's a dial cord that fell off, or if this was used to tie the high voltage lead away. I notice this has a bit of wire wrapped around this. Looks like there was a service tag on here. I don't think that bit of wire or this bit of dial string is really needed for anything, so because I can take those off. Here's one difference: high wattage power resistor mounted up here, and this does not have one. Also notice that this chassis has a bit of a cutout here. I think it's because this was meant to use with a round CRT, and this was not. They used this chassis for several years in a bunch of different models, so I'm guessing there was probably one that had a 16-inch round picture tube. And here's the underside. Big cutout in the wood so you can get at all the parts. And I'd mentioned there were differences. Well, for one, we've got some caps in here, which I think are across the AC line, and this doesn't have any. Some of the other differences I think are from old repairs. For example, I think these might be replacement caps, whereas this has old original wax type. Has a multi-section tap power resistor here, and then a fixed one here as a part of a big bleeder network on the B+ to provide different voltage taps, and they often go bad, so here's a replacement that was just tacked in right on the lugs. Not really the best way to do it, because you never know if this might suddenly reestablish the broken wire ends from getting jostled around. Suddenly you're going to have much lower resistance, and that could definitely cause problems. This one could still be good. Hasn't had a repair done. Alright, so what I'm going to do is get out service info and just get to it and work on both of them at the same time, and be careful of the differences. Like I noticed there's a little ultralytic cap here, but I don't see it over here. So I can't just blindly do the same operation on both sets. I'm going to be a little cautious of differences. Okay, before I dive right into the recapping, actually I want to do a few things. One is gather some service info. So here is a copy of some original service info that Dumont put out. And they have combined RA-112 and 113, which apparently are very similar. Now, I've already noticed the difference between these two, and they're both 113s, but one is a 113B3, and I do have a SAMS for that. But from what I've seen, most of the stuff is the same. Sort of. I'll show you what I mean in a moment. Something else I need to do, as I mentioned, is to track down a yoke and a focus coil. Well, I jotted down the part numbers, so here's part number, the Dumont part number for the yoke, and I found two different, one from the SAMS and one from the Dumont info that aren't quite the same, and then here's the focus coil part number. Well, I looked those up in my Thord Arson TV replacement guide, very handy thing to have. And it cross-references to a Y6, which is a pretty common replacement yoke. It won't be exactly the same as the originals, but pretty darn similar. It has the right deflection angle, the same 560 ohm vertical damping resistors, and I believe the capacitor inside is the same value. So I'll go to my storage locker and see if I can dig one up. It's a little confusing on the service info, but here is that socket, and there is the focus coil. So here's plug in the socket side by side. So there's focus coil. It says 820 ohms, and here's the deflection yoke. So there's those 560 ohm damping resistors I mentioned, and should be well, it says 51 or 68, and there is a note. That's what I meant about saying that these chassis are mostly the same. Circuitry is basically the same, but there are some component differences. Oh, here we go. It's 68 for the 112 and 51 for the 113, and I believe the Y6 actually has a 56 in it. But, I mean, come on, hey, that's pretty darn close. We're just when I get this up working on the workbench, that'll be fine if I can dig up a Y6. If not, I've got some others that should be close enough. Now, what about that focus electromagnet? Well, that would be something like this, which is out of an Admiral. These CRTs required a pretty hefty electromagnet on the neck to focus the electron beam as it travels towards the screen. Whole lot of turns of wire inside here, just like the field coil on a speaker. And there's two leads coming out. I might be able to use this. This is from a 10-inch set, whereas this is a 10-inch round, and this is 17-inch rectangular. But again, just like with the yoke, it's probably close enough. However, a little Tuss CRT I'm going to be using does not need one. It is electrostatic focus, or basically self-focusing. You don't need any coil or anything. You just hook up your heater, cathode, grid 1, grid 2, and it produces a pretty sharp image. So what I can do is just use a power resistor. Unlike, say, a voice coil on a speaker, which both has a DC resistance and an AC impedance, this focus coil only has DC going through it, so a pure resistive load, so I can get by with using an 820 ohm power resistor in place of that. Now I have to use something because it is part of the power supply circuit. I can't just leave it out entirely. Alright, so I think I've got some solutions for the missing yoke and focus coil. Now I want to check the power transformer before I dig in here anymore. So what I've done is taken the 5U4 rectifier tube out, and by doing that, it should just be applying power to the tube filaments, and that's it. This is the only rectifier in it. It doesn't have any selenium rectifiers or semiconductor rectifiers. It's just that. So if you take that out, no B+, no plate voltages in any of the tubes, strictly just going to light up like light bulbs. So I can see if all the tubes light up, that means we've got good filament windings in the power transformer. And if I take a meter and stick it down into the plates on that rectifier tube socket, I can see if we've got secondary voltage. That doesn't necessarily mean there aren't any problems because it's unloaded and I'm not checking for potential leakage or shorts between the windings, but I've had pretty darn good luck. These are pretty beefy, good quality transformers. So if we've got tubes lighting up and a B+ across both plates, so somewhere in the neighborhood of 700 or 800 volts, we should be good. So I'm going to plug in a cheater cord here and plug this in and dim the lights. So when I turn this on, we should see these tubes start to glow. So that power turned on. Now I got to figure out which power switch on the chassis, which I believe is right here. Yes. And right away we've got a pilot light on the tuning dial up front, and the tubes are lighting up. Fantastic. Alright, so that's good. This guy's pretty dim though. Some of these tubes might be burned out. Though it does have the getter on top. Yeah, it is lit up, which is really dim. Alright, so now let's see about that secondary in the transformer. So memory serves 1, 2, 3, should be this pin and this pin. There we go, 790 volts, let's say. Excellent. Alright, so I am going to start working down below. Here we are back underneath the chassis, and I decided to work on the B3 revision for no particular reason. I should mention that before I did that power-up test, I did clip out the safety caps that were going from either side of the AC line to ground. I'll be replacing those with safety-type caps. Something like these guys, which are rated for use on the AC line. And I made a photocopy of the Dumont service info, and I started doing a little work. And I've been highlighting components in yellow as I go. And also, as I've been working on this, I've been looking over at this chassis to see how similar or different they might be. And that gets back to what I mentioned about them being similar, sort of. What I noticed right away is that the circuitry was basically the same, but the components values were different from each other and often from the schematic. And I think it's not so much production changes as it may have been parts shortages, because these were made in around 52 during the Korean conflict, and most of the sets I've worked on from that era have funky mixtures of components. Sometimes they're in parallel, like these two guys right here, because they just couldn't get the right values and the right wattages, so they used what they could. So for example, right here, a vertical oscillator, I'll be placing these two caps, and notice we've got a 5.6K resistor in there. Alright, Well, let's look on the schematic and see if we can find those. Let's see, they are right down here. And notice they show 4.7 or 5.1 with a note. Well, I've got a 5.6, so it doesn't match either of those two values stated on there. And I imagine the note, yeah, they mentioned the difference between the RA-112 and 113. Now, maybe the B3 revision 5.6 is right. Not sure. Now, let's look on the other guy. A little hard to see down in there. And this has a 4.7 in it. And this says it should be a 5.1 for the 113. So, go figure. So what I decided I'm going to do is if things appear to be original, I'm going to go with those values. For something like this, down here, and these obvious replacements, I'll compare them between the chassis, and if one's got the original, I'll go with that value and see how well things match up to the schematic. In other words, I'll use my best judgment on what to use. So I started working on the vertical and horizontal circuits, and I want to replace these safety caps. That's what I'm starting out with. Now when I do the horizontal and vertical, I like to basically replace everything. I don't even bother checking the resistors in the horizontal, because even if they are within spec, carbon comp resistors drift with temperature. And that's typically why after you run a set for a while, you got to get up and adjust a horizontal and vertical hold, because parts start drifting off value as they get warm. Well, by using metal film, which are extremely temperature stable, as are the plastic film caps, it should be a much more reliable set. Also notice the horizontal oscillator tube is mounted on some rubber shock mounts. Very typical of sets. I've seen that in Admirals and RCAs. That's got that tube you want to be, or this oscillator you want to be as stable as possible, otherwise you get horizontal jitters. So they do that to isolate that tube socket from any cabinet vibrations might be produced by the speaker, or possibly even the power transformer if it hums a little. Also notice all these other transformers down here. Well, one of them is dedicated for just the damper tube, which is this guy over here, which technically does not need to be isolated because this tube was one of, if not the first damper tube to be designed to work in parallel with the other tubes. Earlier damper tubes, well, basically would just work like a 5U4 where the cathode and the heater are one and the same. Well, in here, you got some pretty hefty voltages on this tube, and you cannot let them get through to the heater. So even though this tube is designed so that the heater and cathode are isolated, they must have been concerned, well, if this tube ever develops a short, it could take out the power transformer catastrophically and really toast the set. So a nice bit of Dumont engineering to spend the extra money and time and resources to put a dedicated transformer with pretty good insulation on it. I believe it's rated for several thousand volts between the primary and the secondary. The others, well, they use two hefty chokes on the power supply. Another nice touch you don't often see. So usually there's just one filament supply, or sometimes there's two, but they'll do it for like the CRT filament. They won't dedicate one for the damper tube. They'll just trust that the 6W4 won't break down. And if there's a choke at all, they'll typically use a field coil off the speaker. So that's definitely adds some expense and weight and size to the set. And finally, one of these, I'm not sure which of these exactly, is the vertical output transformer. So there's your 4 transformers. Or 5. Main power transformer, damper, filament supply, 2 filter chokes, and vertical output transformer. And we've got all these power resistors in here because of this bleeder network for the power supply. See, it's got a whole bunch of voltage taps, including a negative bus, which makes this set a little bit annoying to work on because most parts are not going to ground. Like all the stuff I've been working on here, it's all referenced to that minus 50 volt bus. It's not most of the parts are not going to ground. So there's a negative bus running all around in here. Why do they do that? Well, it has to do with biasing and how the amplifiers and such are set up. So it actually can produce improved performance because you can use more direct coupling between stages rather than having to capacitively or inductively couple the signals, which can degrade them a bit. Alright, so no surprises so far. Just about got this area done. What I intend to do is shotgun all the paper caps and all the electrolytics and try powering this thing up. So that's when I'll resume recording, hopefully when this is all done, unless I encounter anything interesting, in which case I'll pick up recording there.